Okay, so I've just got the 310 SG tractor in the shop here, and we're going to just do some component location stuff here and have a look around the machine and compare it to this diagram. This is what I call a spaghetti drawing, sort of a a ghosting of the frame and components of the machine that would hide the hydraulic system, and then just looking at everything. So we'll go in the order of the numbers. I'm not sure how logical that is, but left and right swing cylinders they have down here. So that's at the rear of the machine. Obviously this is going to be the rear of the machine. This is the front of the machine. So the two swing cylinders, and you can see the plumbing into the Backhoe DCV, which they're calling number 2. So let's go look at that. So the swing cylinders are in here at the back of the machine. I've got the rear backhoe extended out and on the ground. So there's our swing cylinders. They obviously swing the frame back and forth. They are trunnion mounted cylinders. This plate holds the trunnions in, so there's no pins on the back end of the barrels. The barrels are trunnion mounted. The rods come in and there's a rod pin that hooks to the swing frame to swing the back end of the machine. Cylinders are very close together, so they're all about speed. They're not really about swing force, the way they're mounted. One's going to push, one's going to pull, and that's going to swing the frame back and forth. And then the hoses in that drawing come up to the swing section in the Backhoe DCV. So back here we've got a valve stack. This is a sectional valve, not too much unlike the one on the sandbox excavator we're used to, and it's dedicated to all the backhoe functions. So this tractor loader backhoe, the way Deere does it on this model, they've got 2 or 3 directional control valves depending on the version of the machine. With this serial number break, I haven't been underneath it lately, but I think this one only has 2 DCVs. This one's dedicated to the backhoe. The one up front on the frame, underneath the cab, up front will have the loader and stabilizer controls in it. Some manufacturers like Volvo will have a valve stack at the back here that has all the hydraulics in it for the loader, the stabilizers, and the back end of the machine. But this one, they've broken it up into a couple of different directional control valves. So that's what we're going to refer to as the Backhoe DCV, or the Backhoe directional control valve. It's being fed oil from the pump and feeds the back end, and we've seen the swing. So 3 here, and this is where I don't think this drawing reflects our machine. Even though I pulled up the proper serial number range, it looks like this drawing's a little bit out of whack because they're showing a separate stabilizer valve as number 3. And then I'm going to skip ahead to 16, 18. They're showing the loader valve. I think on this machine, we'll find out when I slide underneath, I think the loader valve and stabilizer valve are actually 1 down in this location. But that's something John Deere changed. Mid-model, it's just a serial number break. They did it one way and then they changed the valve up and did it a different way. So I just slid under the machine to verify that this is what I remembered. Yes, and now we're underneath the frame here looking at, there's the right rear tire, just to give you some perspective. We're underneath the machine. There's our loader and stabilizer valve. So we've got tilt and lift functions, and then we've got the 2 stabilizer controls here, and there's the hoses leaving. The stabilizer functions, they run up here, run over the rear axle, and then run back out the back and go out to the stabilizer cylinders, left and right side. So this machine doesn't exactly match that picture. Where we're going to go next is, I believe, the hydraulic oil filter, a full flow return filter. So while we're under here looking at the other side of the frame, the left side frame, you can see where the full flow hydraulic return filter is mounted. So lots of, like on a TLB, any TLB, lots of the hydraulics are found underneath the machine. So there's not a whole lot to see it walking around the machine. You got to get on a creeper and get underneath. So yeah, it's a little out of whack. That valve is actually combined in our loader control valve that runs the front end of the machine and the hydraulics. So, and then where are we going next? Yeah, as I suspected, number 4 is the hydraulic oil filter. So we just looked at that, mounted inside the frame there underneath. A bit of a vulnerable position. An operator gets this machine mired down in the muck or the rocks, they can damage that oil filter, and that's generally where you find it on most TLBs, in front of the rear axle hanging down there. So 5 is one of the stabilizer cylinders for the rear stabilizers outriggers. The other one's 21 for whatever reason. They didn't go sequentially here, but stabilizer cylinders, we just saw the valve combined with the loader valve on this serial number range of machine. And this can be confusing. You notice they're calling number 5 the right stabilizer cylinder. So which one is that? Well, that's the right stabilizer cylinder. They're pointing to that one. But this is machine left. So that's something to be aware of, especially if you're ordering parts for a TLB. Once you swing the seat around and you're looking out the back window, then right becomes operator's right, left becomes operator's left. So the backhoe right and left are opposite of other parts of the machine, right and left. So that can be a hard lesson if you're ordering parts and you're not sure of the right and left and the pictures aren't clear. So that is actually, even though it's what we normally call the left side of the machine, it's the right stabilizer cylinder. 6 on here is actually an accumulator for ride control or boom suspension. So they're calling the ride control accumulator. That's an option, and the College's 310SG is not equipped with that option for ride control. So we're not going to find that on the machine, nor will we find the valve for it, but it would be a solenoid operated valve. Number 8 is our service brake valve. We're just saying service brake, which is kind of weird because the service brakes are in the rear axle. But they are part of the implement hydraulic system in this version of John Deere machine. They share the same oil with the tank, so they show up on this drawing as part of the hydraulic system, and they show up on the machine schematic when we get there as well. So there's lines coming out of the brake control valve down to the rear axle because we've got inboard brakes hydraulically applied. Not a lot to see of that in the cab. You have to take some tinware off to get at it, but back in here we've got the stops you can see up top, but you've got the linkage going in to operate the brake valve. So these are not automotive brakes. There's not a master cylinder. It's not a master slave type setup. It's full hydraulic. So the brake valve that those pedals operate are 2 independent proportional DCV spools, basically. So you can unpin the pedals and use left and right to independently apply left and right rear brakes. If you've got it in 4-wheel drive, then you've got 4-wheel braking. If it's in 2-wheel drive, well, then you've only got rear braking. So the brake lines only go to the rear axle. But if you've got the drive line engaged into 4-wheel drive, then obviously you can't stop the rear wheels without stopping the front ones. So that's a good operator tip too. If they're on slippery underfoot conditions, they want to make sure it's in 4-wheel drive. Steering valve is number 9. That's here on the drawing. So also part of the hydraulic system. These lines are coming from the backhoe valve, because the first section of the backhoe valve, well, let's back up a little bit and look at where the main pump is. So the pump is mounted, the hydraulic pump is on the back of the transmission. That's feeding up to the backhoe valve stack, or back to the backhoe valve stack, and to the first section, which is our inlet manifold. So just like the valve stack on the sandbox, we've got an inlet manifold, and this inlet manifold, though, is a lot more detailed. There is a priority valve in here that's assigning priority to the supply to the steering. So we've got 2 lines here, because one is the supply to the steering that gives it priority. The other one is a load sense line coming back from the steering, because steering is load sensing. So again, not much to see in the cab here until you start taking things apart. But at the end of the steering column, our steering shaft with tilt steering, we've got a U-joint in there, and then it's operating a rotary directional control valve in the front helm of the machine here, and that again is a control valve that's proportioning hydraulic flow to the steering cylinder. The steering cylinder on this machine is part of the front axle assembly, and it is a balanced double acting cylinder That's turning the tie rod ends to turn the wheels. That system is closed center, and therefore it has to run off a priority valve, and the priority valve is assigning priority to steering over the implement hydraulics. So that kind of makes sense that steering might be a little more important from a safety standpoint than, say, working the stabilizers or, front loader bucket. So priority is given. That's the first place that oil comes from the pump. Priority is immediately given to the steering valve with the priority valve. 10, they're pointing at the hydraulic reservoir or tank. Not convenient to access on modern TLB. We basically all got it here in front of the cab underneath a bunch of tinware, sort of between the engine and the cab. It's a tough component to remove a lot of the times. There's our sight glass that kind of indicates where the tank might be on this machine. So where the tank is sort of right above the cab and right above the transmission, where we'll see our hydraulic pump is driven. And that gives a nice positive supply of oil to the hydraulic pump so it doesn't cavitate. It's got a flooded inlet, they would call that, because you basically got the weight of all the hydraulic oil pushing its way into the pump. So there it is on the drawing. The tank is here, the pump is right here below, and there's a big suction line, which they're not showing. Oh, sorry, suction line's here in blue, they are showing it. So there's the tank. Suction line, nice and short, big suction line, and the pump is below the tank, so flooding the inlet of that pump, making sure it doesn't cavitate. 11, and then jumping ahead to 15, they're showing the two loader lift cylinders. So they're kind of installed on the machine, pretty much horizontal. You might think, gee, that's not very engineered very well. That cylinder's more trying to push the loader frame off the front of the machine than it is trying to lift it up. You think they would have mounted it, maybe this way or something. So yeah, you don't have your greatest lift force through the geometry when the loader bucket's on the ground. But once that loader frame starts coming up, a third of the way, half of the way up, then the geometry changes, and then it is pretty much a straight lift. But because of the compact design, they've got to stick the cylinder in that way. So that's lifting the loader frame. 12 here is showing the hydraulic oil cooler. So it's a radiator basically that they've sectioned away here, and you can see basically the tubes inside that would be carrying the hydraulic oil through. That's mounted up in front of the engine radiator. So when we look in here, we're seeing our hydraulic oil cooler. And there's hydraulic oil cooler lines. Sorry, here and here are the lines. So that radiator is our hydraulic oil cooler. Should also have an air conditioning condenser up here, I think, and then back behind it is the engine radiator. So lots of invitation for plugging with this design. We've got a stack of several cores. Got to keep those radiators clean for the hydraulic system to stay cool, and for the engine to stay cool, and for the air conditioning to work properly. On later machines, on the College's 310 SK, this radiator type cooler got replaced by a water to oil heat exchanger that mounts down on the frame. So they've actually gotten rid of that maintenance point on the newer machines. 13 is the bucket cylinder. So that's we've got a single tilt cylinder on this machine, and the geometry is such that the cylinder extends to curl the bucket shut, which is where you need the greatest force. So they're paying attention to Pascal's law here. And then we're going to retract the cylinder to dump the bucket. And a single tilt cylinder really helps with operator visibility. We don't have a parallelogram linkage on this. 14 is pointing to the front axle. You might wonder what the relevance is of that in the hydraulic system. Well, I guess because it's got the steering cylinder on it here. And you may notice that this steering cylinder doesn't look like the one on our machine. Our machine has a double acting balanced cylinder that's part of the front axle. This seems to have an unbalanced steering cylinder on one side here. And that's because this image is of a two-wheel drive machine. It has a different front axle. It's non-powered front axle. Our machine with the four-wheel drive has, I believe, a ZF axle. Yes, it is ZF. ZF supplies that axle with the steering cylinder as part of it. So John Deere is just employing ZF's design. So 15 we looked at. 16, again, we're back to the loader control valve. So 16's talking about this loader control valve, which on our machine also has the stabilizers in it, our stabilizer controls in it. 17, they're pointing to the transmission because that's, of course, what drives our hydraulic pump. It's driven from a live PTO from the engine, so you don't have to be in gear. As soon as the engine's running, the hydraulic pump is turning. And then 18, they're pointing to the system relief for the loader. Again, our machine's slightly different than this one, so that where that's pointing wouldn't be correct. But they use two different relief valves for two different pressures on the loader and the backhoe. The backhoe runs at higher pressure on a John Deere machine, so get two separate relief valves. So 19, they're back to the hydraulic pump, which we've looked at. Again, suction comes in from the tank, discharge to the priority valve section of the inlet on the backhoe valve. 20 is the rear axle, just because it has inboard brakes. That makes it part of the hydraulic system. And just for reference, stabilizer cylinders we've looked at, stabilizer backhoe valve relief. So 22, they're showing the relief valve here in the backhoe valve section. It says for stabilizers, that's not controlling stabilizer pressure on our machine here because our stabilizer controls have been moved into the loader valve. And then the rest of the numbers are just talking about the color coding that they've used on here. So they're using red for high pressure oil, a lighter pink color for medium pressure, beigey color for low pressure, return oil they're showing as green. Trapped oil they're showing as green, that's odd, and return oil they're showing as blue. So they've reversed that from sort of the Caterpillar standard of colors. So I'm just going to slide back in here on the creeper underneath, and we'll have a look at where the hydraulic pump is mounted. So again, we looked at the hydraulic filter. Here's our transmission. We're looking towards the front of the machine. There's the loader bucket on the floor, front drive shaft, because this is four-wheel drive. So there's our transmission, which is also ZF. And then on the back of it, we've got our pump. So there's our hydraulic pump. Because this is an SG and not a G, the S being super means that we've got a two-stage pump. So there's actually two gear pumps together in the housing. Very obvious that there's, sort of two separate pumps built into this assembly. And there's a suction line coming from the reservoir. So a big flooded inlet coming from that tank that's up in front of the cab, feeding the pumps that are over the rear drive shaft here. And out of this side, we've got the one discharge hose from both pumps. So again, just like the log splitter we've looked at in first semester, we've got two pumps. There is a combining of flows at low pressure and a separation of flows at high pressure. And then that hose here out of the discharge of the pump takes the flow back to the inlet section of the backhoe valve stack. So there's that line coming in, feeding the inlet, and then it flows through the backhoe valve stack up in there. And again, there's a priority valve in there that prioritizes flow, then that leaves and heads up to the steering. So out from underneath the machine, we're looking at that backhoe valve stack, and the oil comes on the front side of the valve back in there. So it comes onto the valve as we just saw underneath, and then it comes to our inlet manifold, which again has a priority valve in it. And this here is our supply hose that's going to head for the steering control valve. So this fitting right here has priority for flow. Once this is satisfied, this line has pressure in it, then that priority valve will let oil go to the other backhoe functions and the loader. And then we've also down here got a load sense hose that's coming back from the steering and telling the load sense system what the pressure requirements are. And then right here, we've got our backhoe section relief valve. So that's going to set the pressure for the backhoe valve section. And then again, up in the loader section for loader and stabilizers, there's another main relief valve. So we've got 2 valves, 2 reliefs. And then this valve stack's got the valve sections for backhoe boom, backhoe bucket, stick on the back end of the machine, and also the extendable stick. This machine's got basically the backhoe boom cylinder. It's one of the functions here, and it is like the sandbox excavator, it's retracting to lift the boom. So just for visibility, they've tucked it in here that way. Not utilizing Pascal's law as much as they could, but compensating it by upping the machine pressure. And then stick cylinder or arm cylinder is going to make the stick work. And then our bucket cylinder up here working the bucket. And then one more cylinder tucked inside the frame of the stick, the box frame. There's a cylinder in there for the extension of the stick, so we can extend the stick. So the controls on this machine, there's a pedal on the floor for the extendable stick. And then this machine has another option that wasn't shown on our original spaghetti line drawing there. We've got pilot control valves for the backhoe controls. So this machine's got optional pilot controlled backhoe loader controls. The loader itself is not pilot controlled. The loader is just good old-fashioned linkage and mechanical valves. On the 310 SG, John Deere did not offer any kind of pilot controls for the loader. The loader was always mechanically operated. But optional at the back is these pilot controlled joysticks. So there's also a feed off of the main pump going to a pressure reducing valve in the control manifold that feeds the pilot controls, because the pilot controls don't work at full system pressure. The hose is coming up in these towers in the back here that feed the pilot control valves is only medium pressure. It's only hundreds of psi, not thousands. So these consoles have the controls in them. And with the pilot control system, you've got a solenoid valve that's operated through a relay and a switch here. We can unlock our pilot controls or lock them. Just makes getting in and out and swiveling the seat backward a little more safety conscious. So again, our control on the floor is for the extendable stick. It is also a mechanical valve. It's not pilot operated, even though this machine has the pilot operated option for the back end of the machine. And here's our stabilizer controls, which are also not pilot operated. And again, on this newer machine than our spaghetti line drawing, there's linkage that's going to the loader valve underneath the floor of the cab, and in the same valve as the loader spools for lift and tilt is where we'd find our stabilizer DCV spools. So some good troubleshooting for the back end of this machine. If ever the back end of the machine doesn't work, your backhoe stick, boom, bucket, and swing is not working, one thing you can try is the extendable stick. If your extendable stick works and nothing else in the back end of the machine works, well, then you know you've got a problem with the pilot control system, because it's not a main system supply oil to the backhoe valve, because the extendable stick spool is in the backhoe valve, but you're mechanically operating it with linkage. So that's just some of the way technicians think immediately when you see a valve that's got some bells and whistles controlling it, and you think, oh, those bells and whistles could break. But when you see there's one function that's good old-fashioned mechanical control, you kind of latch onto that as a future troubleshooting point. Not sure how well we can see up in there, but yeah, there you go. There's the linkage connecting to the extendable stick function. So this function right on the end of the backhoe valve stack. Machine left, but backhoe right. This one on the end is the valve section for the extendable stick. If you didn't have the extendable stick option on this machine, then the valve would be one section less.